Alright, so let's discuss different types of simulations that you have in PSpice that you're going to study in this course. And there are some more simulations that we will not discuss right now, but you will, if you will be taking power electronics, then you're going to do some fast Fourier transforms and all those things that are available in PSpice. So in the introductory video, we created a circuit, which was I believe this circuit, and let me go ahead and zoom in. And I showed you how to grab components from different libraries and then put them together, wire them together. You always need to have a ground. The ground always need to have the value 0. Power supplies are of course there to power up the circuit, but it's possible you may have some circuit without power supply, and those circuits are called natural circuits, and generally they are comprised of capacitors and inductors that can save some energy, and then when there is no power supply, then they can supply the energy to rest of the circuit. In any case, most of the circuits, of course pretty much all the circuits that you will use in this course especially will have a power supply. So in this case we have a DC power supply, and I gave the value of this power supply to be 9 volt. Okay, so when we want to create simulation, so there are 4 different types of simulations, and to create a simulation you have to click on new simulation profile where my mouse is. So you have to give a name to your simulation. I'm just going to call it sim1 and choose inherit from none, create. So the simulation setting window is going to open up. Alright, again, you don't really need to go through each and every thing that is given here, just the important things. So analysis type. As I told you, there are 4 different types of analysis that you will learn to do in this course. And we are going to start with the very last one, bias point, or what we also call DC bias points, or in simple, DC simulation. So when you choose bias point simulation and you run your circuit, basically it is going to show you different values of DC voltages, DC currents, and the power that is dissipated in different components. It's going to print all those things right on the circuit, as I will show you pretty soon. This is different from if you have used multisim. If you're coming from AS program, or if you have taken some of the AS classes like digital systems or some other classes, you must have used multisim. And if you remember, in multisim you have to actually go and put meters, voltmeter, ammeter, wattmeter, to observe the voltage, current, power, so on and so forth. So this is a good thing in PSpice. A little advanced thing, of course. If I would say, if someone is learning how to put together a circuit and where to connect meters to observe voltage, current, power, stuff like that, then the best software is multisim, because you virtually put your meters in multisim, and the same thing you can do on your hands-on on the bench. But for PSpice, you don't really have to put meter. All you have to do is to click on the meter, and the values will be printed right on the circuit, as you will see very soon. So the first simulation is the DC bias point that we are going to do. But I'm going to introduce all simulations right now, and then I'm going to show you DC bias point. Now, the next video, you will see DC sweep simulation. What is DC sweep? Basically, if you have done some labs, or in general, the concept of DC sweep is that you are changing the value of the source from a starting point to the last point, and those values can be in a sequence. For example, I can go and change the value of V1 from 0 to 10 volt with the interval of 0.1 volt. So the value is going to change 0, 0.1, 0.2 all the way up to 10 volt. And when each of this value is going to be adapted by the source, simulation is going to run, and then it will calculate voltage, current, and power and everything in the circuit for that value. Then the next value is going to increase 0.2, and again the same thing is going to happen. It will calculate all the values for different quantities in the circuit, and it will keep on going until it will hit the last value. So you can plot that. You can plot any voltage, any current, any power in the circuit when you sweep the source from initial value to the final value. And you can see how the voltage is changing in a component, how the current is changing, which is passing through a component, how the power across the in a component is dissipating, how it is changing. So that's called DC sweep, when you sweep the voltage of a source and then you observe the change in the quantity in other components. Alright, the third type of simulation is transient simulation or time domain simulation. So as the name reflects, this type of simulation is against time. So as you know, as you're changing the value of time, how the values of voltage, current, power, those are changing in the circuit. Generally, time domain or transient analysis is done when there is a change happening in the circuit. So if you have an AC source, sinusoidal AC source, or a square wave or something, or even if you have a DC voltage source, but you have capacitors or inductors that can charge and discharge to a specific DC value. If you change the value of the DC source, or if you make any change in the circuit, like if you have a switch, you are turning the switch on and off. So time domain or transient analysis is done when you are expecting the simulation to change in a circuit with respect to time. So you use time domain analysis. And the last type of analysis is AC sweep or noise analysis. AC sweep is basically how the values, when I say values, means voltage, current, power, stuff like that, how the values are going to change if you change the frequency of an input AC source. Let's say the power that we get at 60 hertz, 120 volt RMS, 110 volt RMS, right? Assume that you want to change the frequency. You don't want to keep it 60 hertz. So you start with 1 hertz and then you start changing the frequency and you go all the way up to 1 kilohertz, 2 kilohertz, 1 megahertz. Now, many components, especially if you have capacitors, inductors, transistors have capacitor, inductor, and other electronic components always have inside capacitance and sometime inductance. So anytime capacitors and inductors, they are acted upon by input with different frequencies, their reactance change and they behave differently at different frequencies. So when you change the frequency of the source, generally your circuit output or circuit values, if the circuit has electronic components or analog components like capacitors or inductor, the value of voltage, current at different frequencies are different for those type of circuits. If you just have resistors, in general, ideally, in general the resistance does not change with the change in frequency. Now actually it does change if your frequency becomes quite high. Then the charges, basically through a resistor, charges start accumulating on the surface. So the effective area of resistance goes down and the resistance value increases. But in an ideal world, we assume that, and that's called skin effect. But in an ideal world, we assume that there is no skin effect. So without changing the frequency, if you just have resistance in the circuit, your output is not really going to change. It will always be the same at all frequencies. But if you have inductors, capacitors, transistors, diodes, any other ICs which are made out of transistors and all those, their output, their response, it changes with respect to frequency, AC frequency, and those type of response are analyzed using AC sweep analysis. So once again, we have these 4 types of analysis, and you're gonna do all these type of analysis in this course. So we are going to start first with DC bias point. And observe that it's very simple. Just keep it at general settings. You don't have to do anything. Just to apply and OK. Alright, now observe that all these buttons, they are enabled, right? So what we're gonna do, we are going to create the simulation. We're gonna run PSpice, right? From this run button, we're gonna run PSpice. Now the PSpice window is going to open up right here. I'm gonna expand it. Now in this window right now you don't see anything, right? This specific window right here in the bottom, this is the status window. So you can see, what does it say? Reading and checking circuit read and checked, there are no errors, calculating bias points, and it shows you what's going on in the simulation. Now if there is an error in the circuit, then you will see an error right here with a red mark that there's an error in the circuit. This window next to the status window, this is for the cursor. We're going to discuss cursor sometime soon. And then you have the command window and other things. We are not using them right now, so no need to discuss that. Observe that there is no simulation right here in the PSpice window. Why? Because you are doing DC bias point or bias point simulation, and as I mentioned, all the DC values are printed on the circuit. So you don't really, there is nothing that will appear in this screen. Although the PSpice is going to run, because PSpice is a simulator, remember. You were using a schematic editor so far, the ORCAD. Now once you run the simulation, PSpice window is going to open because the simulation is running. But for bias point, nothing is going to be shown here. So I'm going to minimize this. And then you have these three V, I and W. You have these 3 meters. If you press V, then it's going to show you all the voltages at different nodes with respect to the ground. So you have a 9 volt here, and you can move this. It's going to show you with a line that this voltage belongs to this node, and this is the same node as this whole thing because it's the same wire. As long as there is the same wire and there is no component, then the wire will contain the same voltage with respect to the ground. So you have 9 volt with respect to the ground. You have 7.568 volt over here, this node, all this area right now, you see this area, that's 7.658 volt with respect to the ground. And then you have 4.198 volt, all this area that you see, that's 4.192 volt with respect to ground. So these are the voltages, node voltages, what we call node voltages. Now if you want to know what is the voltage across R3, right, and remember R3 voltage is not 7.568, that's the voltage at the beginning of R3 with respect to the ground, what we call over here the node, this node. See, the name of this node is N00138. So the N00138 node, the voltage is 7.568, and on the other side R32, or the node number is N00151, the voltage is 4.192. So if you want to know the voltage across R3, all you have to do is subtract 4.192 from 7.568. So that's going to be the voltage dropped in R3, right? So if I ask you what is the voltage dropped in R3, all you have to do is to subtract 4.192 from 7.568, and that's the voltage dropped in R3. What's the voltage dropped in R2? Now R2 voltage on top is 7.568, at the bottom is 0. So the voltage drop is 7.568 minus 0, which will be 7.568. Anytime a component is connected to the ground, one end of the component is connected to the ground, then the node voltage on the other side is the voltage across that component, because when you take the difference between the two voltages, of course the voltage on the other end is going to be the voltage after you take the difference. So these are the bias point voltages and at different nodes of the in the circuit. If you want to know how much current is flowing through each component, all you have to do is to press I, and I can depress V so that voltage can go away. Alright, look at that. 14.32 milliampere is flowing through R1. At this point it's 14.32, so it will come out to be 14.32 as well. 7.6568 is flowing through R2. 6.753 milliampere flowing through R3, 2.096 milliampere flowing through R4, and 4.657 milliampere flowing through R5. And through the source, 14.32 milliampere is passing through the source. Again, that's the same current that is passing through R1, because current is going to come out of the voltage source, go through R1, then it's going to be divided into R2 and R3. The current that is passing through R3 will further divide into R4 and R5, and then it's going to go back. All the currents are going to sum up, and 14.32 milliampere is going to be the total current coming out of the source. So that's the current values. Those are the current values. And the last thing is how much power is dissipated in each source. So we are calculating power dissipated, not power supplied. So resistance always dissipate power, consume power. So observe 2.51 milliwatt in this resistor, 57.27 milliwatt in this in R4, this is in R5. All of them are positive, because again these are power dissipated. Observe the source, negative 128.9 milliwatt. Why negative? Because source is supplying power, not dissipating power, not consuming power. It is supplying power. So since all the power is given in terms of dissipation, then when the power is supplied, it is represented as negative power dissipated. So negative power dissipated or negative power absorbed means positive power supplied. So basically source is supplying 128.9 milliwatt, which is the sum of all these powers according to the conservation of energy, that whatever power is supplied by the source has to be equal to the power consumed in the circuit, or energy supplied by the source has to be equal to the energy consumed in the circuit. So these are powers in different components. You can have all three of them clicked at the same time, so you can see how much voltage, how much power and stuff. Sometimes it just get a little messy. It can come on top of each other. It can come on top of the values of resistor and stuff. So I don't really like to see all of them together. It is good if you just observe one, then click it back, observe the other, then click it back, observe the third one, stuff like that. Okay, so this is PSpice simulation. Let's talk about how you're going to submit the homework. So if, let's say this is one of the problems of the homework. So what you're going to do, you are going to, let's see, where is my Microsoft Word file? Right here. I'm going to open a Word file, plan document. Okay, so you have a Microsoft editor. You're gonna start with, of course, your name. Let's say Masood Ijaz, homework number 1, PSpice, Control U. Alright, let's say this is my exercise number 1. Exercise number 1. So what you are going to do is you are going to go and copy the circuit. I'm gonna just copy the circuit without any simulation. Okay, and to copy the circuit you can do multiple things. You can just enclose it with the left mouse button, just keep it pressed and then enclose it, and then copy it, Control C, or right click copy, and then you're gonna go ahead and you're going to paste the circuit over here like this. So first you are going to copy paste your circuit that you have created in PSpice, and then you're gonna go ahead and copy paste simulation that you are doing. So let's say I want to show all the voltages. I put all the voltages and I'm gonna go ahead, copy and paste. These are my DC voltages. Likewise, if I ask you to show me currents as well, then you can go ahead and show me currents as well, and copy, Control C and Control V. So you're gonna first copy and paste the circuit, original circuit without any simulation, and then whichever simulations are required, you're gonna run the simulation, and then you're gonna take the picture of that simulation. Either you use a snapshot or you can just copy and paste, whichever way you want to do it, doesn't really matter. And you're gonna paste those in a Word file, right? So let's say this was my exercise 1. So this is how you're going to put the exercise 1. And let's say I have exercise 2. So you're gonna first do exercise 2, control U, and so in the next video when I'm going to be explaining DC sweep, let's do an exercise in that and then put it as exercise 2. So I'm gonna go ahead and finish this video with the explanation that we did for the DC bias simulation.